Okay, let's work through this together. Side AD is congruent to side ED, that's given to us, and D is the midpoint of BF. So we're going to end up knowing eventually that that is congruent to that. But we're going to have to establish that first. So before we know that, actually, let's go back and just say we don't really know that yet. We need to establish that. And how do we establish that? We need to first state what we know is given to us. AD, side AD is congruent to side ED. And we just need to write this out because it's something we'll be building on. D is the midpoint of side BF. Those were both given to us. And where do we go from there? Well, obviously when they tell us that something is midpoint, where they're going with that is that you've got two congruent segments. So let's write that as the second step. Let's establish that too. Segment FD is congruent to segment BD. And how do we know that? Well, that's what a midpoint means, that it splits it into two congruent segments. So definition of a midpoint. Great. Okay. You can see, and I'm just going to highlight the in yellow, and then I'll take it away, the two triangles that we're trying to prove, that ADC oops, and EDG are congruent. Do we know this stuff now? Well, one thing that we do know, we've got one side here we can see that's already established as congruent. Do we know the rest of it? Not yet, but let's see what we can build to from there. Let me get this all out of the way. Okay. It appears as though we've got two triangles, these triangles as nearly congruent. And what else would we need? We would need the included angle would be really helpful, or the other side, but the included angle is easy because they're vertical angles. So if we can establish that, let's see what we know then. Okay, we can establish that that is congruent to that. And then we would have the triangles congruent. So let's see if that's helpful to us, if we establish that's congruent to that. And by the way, which triangles are we trying to prove? That ADC is congruent to EDG. Well, if we can prove that the yellow ones are congruent, then we have this common angle that they share being congruent. And that would be really helpful for the triangles that we're trying to deal with. So let's prove that. Let's say we know that 3, we know that angle ADB is congruent to angle EDF. That's vertical angles. And how does that help us? Well, because once we establish that, and I'm going to put those marks there, then we know that those triangles are congruent. And we can then talk about the corresponding parts. Specifically, the corresponding parts that we want to talk about is that angle. Oops. That angle is congruent to that angle. That's going to be helpful for us. Okay? So let's do that. We can say 4. Okay, now we know that the whole triangle, what can we call it? We can call it the one on the left, triangle FDE is congruent to triangle BDA by side angle side. And then we can say, knowing that, we can say that angle E is congruent to angle A by CPCTC. What we've proven there is that this angle is congruent to this angle. Okay, I'm going to mark it in blue, that angle. Congruent to that angle. And so on the triangles that we're trying to prove, ADC, that's in yellow here, this, ADC, we already know that we've got an angle in blue and this side right here congruent. We're trying to prove that congruent to EDG right there. Okay. Well, what do you know about these two triangles? I know it's a lot of sloppiness, but if I trace this out, we know for this triangle right here, we know that angle and then that side. For this triangle we're trying to prove is congruent to it, we know that angle and that side. And by the way, that needs another angle mark to be true. I don't know where that went. So we could then, using angle, side, angle, prove congruence if we only knew that this angle right here was congruent to this angle right here. And hey, what do you know? They're vertical angles, so we can do that. That's really super easy and great. So 6, we can say angle EDG, angle EDG, that's this, EDG is congruent to ADC, angle ADC. How do we know that that's true? They're vertical angles. And once we know that, we now know that that must mean that this triangle here is congruent to that triangle there, which is what we're trying to prove, that ADC is congruent to EDG. And we know that now because, and I should put in those angle marks, this angle is congruent to that angle. And now we've got angle side angle congruence with those two triangles. So we can then say 7. Okay, now we know that triangle ADC is congruent to triangle EDG. How do we know it? We know it through angle, side, angle. Might be worth to watch that video again to see it if you didn't see it. But what we did is we established that the smaller triangles were congruent, the smaller triangles being these here. And then we were then able to take that information and say, well, that angle and that angle are congruent. We already knew that those sides were congruent, and these angles are vertically congruent. So we've got angle, side, angle congruence, angle, side, angle congruence. Watch the video again if you need to, and you can see it all come together. Hope that was helpful.